Good morning, my lovely twelvers. Right, buddies, here we are in our next lesson in awesome, amazing mechanics, the best module out of all the modules in the whole of A-level, I think. I'm not biased at all, really, though, but yeah, I might love this module. Here we go. Title today is Tricky SUVAT Practice Lesson. Now, just like I promised last time, do you remember last lesson how I made you do a whole whack of questions, but you kind of focused on the easier ones where you could just figure out what the numbers were that went into the list, and then you could pick your equation and solve it. Well, that practice was absolutely necessary because now I'm going to chuck the easy ones away and we're going to do some hard nightmare questions together. So let's do it, buddies. It's the same as last time, but just they're a bit harder. So let's try. Okay. Oh, and I put the SUVAT equations here for your convenience. If you haven't got them memorized yet, it's okay if you don't ever memorize them because they are in the formula book, but there they are for your convenience in the margin. Okay. A particle is moving in a straight line with constant acceleration. You need those words. Why do you need those words, constant acceleration? That's it, because if we don't have constant acceleration, we don't have SUVAT. You guys know that SUVAT was derived from that velocity time graph. Oops, that's a highlighter. Ooh. You guys know that SUVAT was derived from that velocity time graph that looked like that, remember? Now, if that line wasn't straight, SUVAT doesn't work. And that line won't be straight unless the acceleration is constant. So it's good that they included that. But anyway, sorry, I'm off on a tangent already. Now, here's what it says. The points A, B, and C lie on this line, and the particle moves from A through B and to C. The velocity of the particle at A is 2, the velocity of the particle at B is 7, and the particle takes 20 seconds to move from A to B. It wants you to say the acceleration of the particle. Okay, straight away, this question is too complicated. I do not like it. So what are we going to do? How do I simplify before writing SUVAT? Well, a picture. A picture is going to be worth 1,000 words, my buddies. Let's do it. It's on about a line. So it's written, it's one of those mathsy ones. It's written as maths rather than physics. Okay, A, B, and C, it said we're all on a line. So let's help ourselves figure out what's going on by looking at that. Now, it does say some bits and bobs as well. It says that at A, the velocity of the particle is 2 meters per second, and it says it's going towards C as well, so it's going towards C. And at B, it's 7 meters per second, okay? At B, it's 7 meters. I'm going to draw it above, actually. 7 meters per second, 2 meters per second. Cool? So there we go. That's the information that it gives us. It also tells us that it takes it 20 seconds to get going that far. So it took it 20 seconds. Go to green. It took it 20 seconds to get from A to B. So that took 20 seconds. Okay. And it says find the acceleration of the particle. Well, no problem, actually. So I said this was a really hard question, but actually it's not too bad. Everything's moving right. It is speeding up as well, so the acceleration is toward the right as well. So you ready? Pick a direction to be positive. Right, because everything is right, or everything is moving right in this question. This is going to become really important later on, the direction convention. But you pick whatever you want. Right, because everything's moving right. Clearly. Okay, ready? SUVAT. SUVAT. Okay. Now let's do it. What do we know? What do we know? Well, we do know for sure. The distance, well, we don't know that, so question mark. Do we care what it is? Nah, bin it off then. Don't even put a square on it. U is 2 meters per second. V is 7 meters per second because it starts at A and ends at B, so that's the first, that's the final. Acceleration, we don't know, but we want it. Square around it. T, yeah, 20 seconds. Right then, my buddies. What SUVAT equation do we want? We want one that doesn't have Sn. If you said it's the top one, you're absolutely right. V equals U plus AT. Soon you'll spot these instantaneously, my buddies. And here we go. Put the numbers in as you see it. 7 equals 2 plus A times 20. Cool? You can solve now in one step if you like. I'm going to show 2 steps just because I want to make sure I don't leave anyone behind, but there's no marks from here on in. Mark for subbing in, no marks here on in until you get to the answer. So you ready? I'm going to take off 2 from both sides. 5 equals 20A, no mark for that, which means that A is 5 over 20 or 0.25 meters per second squared. It came out positive. That means it's accelerating toward the right, which is exactly what we would have expected. So happy days, buddies, we're flying. Cool, B. In B, it gives us more information. It says the velocity of the particle at c is 11. So now we can put that into our thing as well. So at c, it's 11. Presume it's going the same way. Well, because it is speeding up, 11 meters per second. And what does it want this time? It wants the time taken for the particle to move from B to C. So it's after this time, isn't it, this time? See how the picture's helping? Do you guys see how the picture's helping? Well, it's definitely worth drawing, wasn't it? Cool. Well, approach it the same way. This is no problem to us. This is no bother. We are legends. Here we go. Pick a direction to be positive. Right, because everything's moving positive to the right. SUVAT. SUVAT. The question is different this time, so we have to rewrite the SUVAT out. And let's pop some stuff in that we know and some stuff in that we don't know. So to start with, what do we know? Do we know S? Do we know the distance? Well, no. We don't know the distance. Do we know U, the initial speed? Yeah, this time it's the 7, because we're going from B to C this time. Do we know V, the final speed? Yeah, 11. Do we know acceleration? Maybe. And do we know time? No, that's what we want. Do we know the acceleration? Yeah, we do know the acceleration. What's the acceleration? Well, it's not 0.25 meters per second squared. Why is it? It's because it is a constant acceleration. It says that in the very first line. So the acceleration is the same throughout this whole question. So we can pop the 0.25 in that we got as our answer for the last one. Cool beans. So we need one that has t, but hasn't got s. Which one is it? Oh, it's the same one again. How boring. So it's v equals u plus at. Cool. V is 11. 11 equals 7 plus 0.25 t. Oh, look at me skipping a step already. But happy days with that, right, my buddies? Which means 11 take away 7. I'm going to skip this step too. No, I'm not. Stop being naughty. Okay, here we go. That's 4 equals 0.25 t. No mark for that, though. Multiply both sides by 4. Divide both sides by 0.25. T is 16. 16 seconds. Seconds, because I had these standard units, so I knew that the unit was going to be seconds. Cool, cool, cool. And the final thing then, my buddies, is going to be this. C, which is meant to be a bit of a trick question, but it's not too bad, to be honest. It's supposed to be a bit of a trick question. Find the distance between A and C. Well, check it out, my buddies. You've got two options. What do you think? Pause and tell me what you think. Okay, here's what most of you will think. Most of you will probably think this. You'd be like, right, use this bit to get this distance, use this bit here to get this distance, and then add the two distances together. Am I a mind reader? Is that what you're saying? Yeah, I am a mind reader, and yeah, that is what you're thinking. Probably most of you thought that way. Now, I bet none of you thought like this. Maybe some of you did. If you're proper at the lazy level like me, you know that actually this entire distance is kind of describing the same motion. The green is describing the same motion. It's constant acceleration all the way from A to C. So I'm going to put them together as one and solve in one foul swoop. So you ready? I'm going to consider from A to C. Right is positive. SUVAT. You can do it your way though. The pink, the blue way, and the yellow way together does work. So go ahead and do it that way if you prefer. Okay, S, the entire distance. Do we know that? No, actually, and that's what we want to solve. Okay, the initial speed from A to C. Well, the initial's 2, because it starts at A. Final is 11, because it finishes at C. The acceleration, do we know that? Yeah, it's a constant 0.25 meters per second squared throughout. Do we know the total time? Well, actually, we do. I think we do. Don't we know it? Yeah, 20 plus 16, so it's 36 seconds. We know that as well, don't we? But we don't even need that. We had enough with just this. So isn't that cool? Like, look, we knew it was, because we knew it was, yeah, here, look. I don't know if I'm explaining it clearly enough. That is 16 plus 20. We knew it was 36 seconds for the entire distance. That's what that is. But actually, we don't even need that. So this question, we could answer this question before we even did the whole anything else. So I'm going to use the one that doesn't have t in it. And so I'm going to use this one. I'm going to use v squared equals u squared plus 2as. Cool? So in other words, 11 squared is going to equal 2 squared plus 2 times 0.25 times s, which means 121 equals 4 plus quarter of 2. Is that 0.25? No, it isn't. Yes, it is. It's 0.5, isn't it? Oh my gosh, I don't know why I'm struggling. 2 times 0.25. Yeah, of course it is. 0.5. Oh, sorry, buddies. Mind blank for a minute there. S. Cool. Work it out. Get what S is. S is going to be straight away 121 take 4 equals, divide by 0.5 equals 234 meters, which will be exactly the same answer as you guys just got, okay? So no matter how you did it, we would have arrived at the same answer. And then you got it. Happy days. Cool beans, buddies? Right, there's a hard one. Here you go. Here's a really hard one. Oh, and then a really, really hard one. Oh gosh, it's a big lesson again today. Okay, a particle is moving in a straight horizontal line with deceleration of 4 at time. Yeah, okay. At time 0, it passes through the point O with speed 13, traveling toward the point A, where OA is 20. Oh my god, it's one of those really horrible ones. Okay, you ready? Constant deceleration 4. They've written it to look like a maths question, even though it's a physics question. At time 0, the particle goes through O. So at 0, it goes through O, and it's got speed 13 there. It's traveling toward A, where OA is 20. And now it wants you to figure out the times, this is plural, that's interesting, that the thing passes through A. Okay, let's do it. So here we go. We've got O, we've got A, and a picture is going to help, right, in this one, because it's a little bit fiddly, isn't it? Okay, if it wasn't fiddly, I wouldn't draw a picture, but this one is fiddly. Now here, what do we know? Well, we know at O, it's got speed 13. I'm not going to call that U or V or anything yet, because I'm not quite sure what I'm doing yet. 13 meters per second. We know at A, well, we don't know anything at A, actually. We know at OA, we know the distance that it is 20 meters. Oops, I wanted that to come in green and it came in blue. Okay, 20 meters. It says it's 20 meters between them because it says OA is 20. And we don't know the speed or anything there. We don't really know very much around there. It does tell us one other thing though. It actually tells us that there's a constant deceleration of 4 meters per second. Here's how you write that, buddies. This is going to be a bit fiddly for you, but here you go. First things first is it's a deceleration. So is the 13 going to be increasing as we go toward A or decreasing? Well, decreasing, which means we're going to draw ourselves our acceleration going this way. Now, to make it ready for the next unit, here's how you draw an acceleration. You draw a straight line with 2 arrows indicating the direction it's going. A is equal to 4 meters per second squared. Cool? So while it is traveling toward the right, its acceleration is toward the left. And this is why it's a deceleration. And this is why I didn't want you to do these questions last week, because I think you needed just to get started. Okay, so let's do it. Let's see if we can work it out together. Now, step 1 is always the same. Define a direction to be positive. In my head, the thing is moving toward the right, right? It's going from O to A. So I'm going to say that right is positive. Okay? SUVAT. Let's start popping things in. Do we know S, the distance that it has to go? Well, yeah, it's 20 meters. 20 meters. Cool. Do we know U, the initial speed? Yeah, it's 13 meters per second. Do we know V, the final speed? Do we know how fast it's going at A? Well, no, actually. The question doesn't tell us anything about that, so we don't know that. Do we know acceleration? Yes, we do. It's 4 meters per second squared, but there's a trick to that. Do you remember how you said right was positive? Yeah, we said right was positive. Well, what way is the acceleration going? Well, left. So if right is positive, but the acceleration is going left, this is a negative 4, buddies. Get me? It's about direction. It's not about it being a deceleration. It's about a direction. If you said right was positive and you have something that's going left, then that must mean that that thing's negative. T we don't know, and T is actually what we want. So we'll put a question mark in there, and we'll draw a square around it. So I need the one that doesn't have V in. So which one's that one? That's it, my buddies. It's s equals ut plus 1/2 at squared. Cool. Whack your numbers in. Let's do it, do it, do it. So numbers in, s is 20. 20 equals 13t plus 1/2, a is -4, t squared. So in other words, 20 equals 13t minus 2t squared. Oh no, buddies! We can't solve it! There's different powers of t! If only there was a way to solve this! That's right, buddies! You can solve it! It's a quadratic! How exciting! Put everything together on one side. 2t squared minus 13t plus 20 equals 0. I moved it all left. Wouldn't it be wonderful if this actually factorized? Is there two numbers that times to make 40, but add to make minus 13? 8. Oh, there is. Oh my god, yeah, there is. Okay, sick. Okay, right. 99.9% of time, this is quadratic formula now, buddies. So in physics, you don't often get to factorize them. You can tell this question is contrived. It's made up to work. Okay, sick. Yeah, normally it's quadratic formula. This actually works, though. How exciting. We're looking for two numbers that times to make 40 and add to make minus 13. What are they? Well, yeah, minus 8 and minus 5. Ledge. Okay, sick. Let's do it. I'm going to show the middle step for supporting your quadratics. 2t squared minus 8t minus 5t, splitting the middle term, plus 20 equals 0. Okay, factorize the first two. You're going to get 2t. T take 4. Factorize the second two. Take a minus 5. T minus 4 equals 0, which means that you're going to be left with, let's go up here, whoop, and let's go brackets, t take 4, and 2t take 5, 2t take 5, which equals up to 0, which means our final answers are two answers. T is 4 seconds, okay? Seconds, we need units. And this one here, t is equal to 5 over 2, which is 2.5. Cool? Like a boss. We've just answered A. Weird. It's got two answers and both of them are viable. So isn't that funny? Now, I'm going to go off on a tangent. Why would you have two answers? Can anyone think as to why? It's right, actually. It's right that we had two answers. It's because here's what's happening. So I'm going to scribble on this, then I'm going to erase it. So it's just a one-time shot. You start at O, right? And here's what the particle does. It starts off going 13, it goes slower, 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 boom, and it passes through A, but it's slowing down. It passes through A at 2.5 seconds. Then finally it stops here, okay? And then it starts coming back and bang! Now 4 seconds into its journey, it continues all the way back to the start. So it crossed A once at 2.5 seconds, and the second time it crossed was at 4 seconds. Get how it overshot it, and it came back. That's how it works, my buddies. Happy days. Cool. So that's why that worked. And see, it's tricky a little bit. And the final question, B is actually not as bad if you can remember a bit of a trick. Okay, B says, find the value of t when the particle returns to O. Okay, trick question. If you can spot it, you're going to be on fire, though. Okay, right is positive. SUVAT. S-U-V-A-T. Okay, pop in what we know. Now, here's the thing. If you're really clever, here's what you can do. If it starts at O, it goes off, it does its thing, and it comes back to O. What's its displacement? You're right, 0 meters. Because it ended up where it started. Remember how displacement is how far you've gone based on where you've started? It's different to distance. It's different to distance. It wants displacement. So 0 meters. Initial speed, 13 meters per second. Final speed is, it's going to be minus 13, but I'm not going to tell you that. Unknown. Acceleration is minus 4 meters per second squared. And the distance that it goes is also unknown. No, it goes 0. V is unknown. A is minus 4. Oh yeah, of course. T is what we're after. Yeah, sorry about that. I don't know what I was thinking. There you go. T is what we're after. So we need the one that doesn't have V. Which one's not got V? That's it, buddies. It's this one. It's the S equals ut plus half at squared. S equals ut plus 1/2 at squared. Displacement 0. V. This is going to be 13t plus 1/2 minus 4t squared. So 0 equals 13t minus 2t squared. And check it out, my buddies. It's a quadratic again, and you can factorize it. 0 equals t, open bracket, 13 take 2t. It's just a common factor. This one's easier, which means that we get two answers. T is 0, which is an answer. That's a viable answer. We'll talk about that in a sec. T is 0. And this one here, you get 13 equals 2t. 13 divided by 2 is 6.5, so t equals 6.5 seconds. You got two answers. Now, one of them we're going to bin off. So, and here's why. Find time when the particle returns to O. Well, at time 0, it's already at O, so it's not that one, because that's when it starts at O as well. By the time it's finished its journey, it's taken 6.5 seconds. Whew! Hard questions. I like it. Last one. For you guys to try all by yourselves. It's very hard, but I think you can do it. Particle P is moving on the x-axis with constant deceleration of 2.5. At time t is 0. Deceleration 2.5. At time t equals 0, the particle P passes through the origin O, moving in the positive x direction with speed 15. Find the time between the instant when P first passes through O and the instant when it returns to O. Okay, my buddies, let's try. Okay. Right. What should we do first? You go. You try. Go. Draw it. Oh, I spoiled it. Try, my buddies. Do it. That's right. You're going to want to draw for sure. So let's do it. It says it passes through O at time 0. Passes through O. Positive direction of x with speed that. The instant when it returns to O. And then it goes out this way. But it doesn't tell us any other letter, does it? It goes out that way. Okay. Now, the entire thing, it's got minus 2.5 that way as an acceleration. Minus, leave it positive because I didn't define the direction. So 2.5 meters per second squared that way is the acceleration. 2.5 meters per second squared. The moment it passes through x, it's got at time t equals 0, the particle passes through O, so we're at O. And it's moving in the positive x direction, so it's moving right at 15 meters per second. 15 meters per second. And that's it. And that's great. I think we've got everything in there. And it says find the time between the instant when P passes through O and then returns to O. So our journey looks like this. We leave O and we come back to O. So that's essentially what the question's asking. SUVAT. Pick a direction to be positive. I'm going to pick right because the motion is positive. Okay? What distance does it go? Well, we don't actually know. What's the initial speed? What's 15? So here we go, 15 meters per second. The final speed, don't know. Acceleration, well, it's 2.5, but it's 2.5 to the left. So minus 2.5 meters per second squared. And the time is what we want. We want t. Oh no, so I haven't got enough to solve. I only have 2 things. I need 3. If only there was something that I forgot about. That's it, my buddies. We do know S, don't we? It started at O, it ended at O. What's the distance that it's gone? 0. Like a boss. So we need the one without V. S equals ut. Ut plus 1/2 at squared. Cool. S is 0 though. 0 equals 15t plus 1/2 negative 2.5 t squared. Cool. 0 equals 15t minus 1.25 t squared. Take a t as common. T. 15, take 1.25 t. And then that means we got our 2 answers. T equals 0 or t equals 15 divided by 1.25. 15 divided by 1.25 is 12. 12 seconds. Which one is the real answer? Well, it's 12 seconds because it started at time 0 at the origin and it's returned there after 12 seconds. That one you discard. 12 seconds is the answer, like a boss. Now, here we go. The only reason I wanted to do this question is look at that word. The distance. traveled by p in that time. Okay, so the distance that the particle goes. It's a tricky question. It's not 0. It should be 0 because it's like it ended up where it started, but it's not 0 because it says distance. We need to get the entire distance. It doesn't matter about direction. It's just straight up how far did it go. Well, here's how you do that. You have a little think. Pause me right now if you like. I'm still going quick. I know I'm going really quick right now, but pause me if you like, if you dare. If you think you can figure it out, go. And if you haven't figured it out, here you go. Here's how we can do it. Get the distance it goes. Well, it's not good to say 0, okay? We need the whole distance it actually traveled. If you went from Stratford to Ulster, it's 8 miles. Then you went back home again, it's 8 more miles. So 16 miles is the distance, even though the displacement's 0. So here we go. Here's what you can do. We need to get this end point. Something's up about that end point, though, where it changes direction. What do you notice about what's up there? It starts going 15 meters per second. It goes slower, 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 slower. Stop. Then it comes back. That cross v is 0. Its final speed is 0 because it has to stop before it can change directions. Cool? Which means, buddies, what we can do is we can SUVAT to get how far it is and then double up that answer. That's what we're going to do. So for part B, let's do it. Pick a direction to be positive. I'm going right again. I'm very unoriginal. SUVAT, S-U-V-A-T. Okay, and in it, here we go. S, do we know S? No, it's actually what we want. And we're getting a displacement here and not a distance, which means that we're going to have to make sure we don't have any backtracking if we want those things to work out. U, the initial speed, yeah, 15 meters per second. The final speed, yeah, it's 0 because it has to stop before it can come back. Acceleration, well, yeah, it's 2.5, but it's to the left, so minus 2.5 meters per second squared. Time, how long does it take? Dunno. And, oh, I'll put a T there instead of a question mark. How long does it take? Dunno. And do we care? No. So I need the one without T. Let's do it. V squared equals U squared plus 2AS. So let's do it. 0 squared equals 15 squared plus 2 minus 2.5 S. So 0 equals 225 minus 5S, which means that S equals 225 divided by 5 equals 45. 45 meters. Now, is that the final answer? Well, no, because that means this is 45 meters to get to there, right? Which means how far is it back? Another 45. Yeah, got it. 45 meters back too, right? So total distance, it's not displacement, it's distance, and this is where they try to throw you off, is equal to 45 times 2 equals 90 meters. Cool, because it has to go there and back. Bit of a trick question. Okay, now in the remaining bit of this lesson, so hopefully you followed along with me, in the remaining bit of this lesson, I'm going to get you guys to try some mixed practice, and watch this magic trick, my lovelies. It's as though I forgot to put the questions here, but with the snap of my finger, they're going to appear. So are you ready? And there they are, my buddies. How exciting is that with the magic of the internet? It looks like I forgot something, but I totally didn't forget it and just added it together. Okay, so here's what we're going to do. Page 140, question 9 to 13. Do a mix though, okay? So do go for some hard ones, go for some of the tough ones in there, and again for 7 to 15 on page 145. Page 145 is the harder of the two, so I would certainly have a look at 145 potentially first to make sure that you can do these hard, horrific ones, okay? 145 I strongly recommend first, and then the others. Cool beans, buddies? When you're all done, send me a nice example of your work, spend the rest of this class time and an extra 20 minutes for your homework to take the place of homework, because I need you to be so good at these, my buddies. You can get A stars in mechanics for sure. So that's it, my buddies. That's it from me, and see you next time. Bye, buddies!